Hello everyone. First of all, I welcome you to this course. I will ensure that you will enjoy this course. But in case you feel something needs to be improved, I am all ears and definitely your suggestions, your tips will be implemented in the course. Before we start, let me give you a quick overview of this section. I have designed this section in such a way that this section will be equally applicable to any tool. So even if you are learning Hypermesh, ANSA, Abacus, LSDyna, Nastran or any CAE related tool for that matter, this section is essential one. With this section, we will try to build the foundation for CAE. We will understand how the product development usually happens, what exactly is CAE, what are the things that are possible in CAE, how CAE works, what is nodes and elements, various ways through which we can solve the engineering problem, and many more. Point being, in this section, since we are going to cover all the fundamental things, in my course you will find this section more or less common. With this note, let us begin our journey. In this session, we will take a look into exactly what goes into the product design and development. One thing I would like you to do is to take some time and observe around you and list some of the mechanical product. For example, I have a monitor, fan, mobile phone around me. We also have the different bike and cars at the parking lot of a building. Now think 10 years back. At that time also we had this product, but see how far we have came in terms of design, aesthetics, ergonomics and efficiency of the product. Friends, my question is why we need to develop so many new things? You see, if we take a look into most of the product, we already have them. We already have the smartphones, but yet every 4 months there is a new smartphone by the same company. Or after every year there is a new car by the same automotive company. One might wonder what exactly goes into designing of this new product. An answer to this is given by the PLM, which stands for Product Lifecycle Management. PLM describes the necessary steps through which our product goes from its birth to its recyclation. Now, to answer our first question, why we need to create new things, then simple answer would be we innovate the new things because we have a need. For example, if I look back in the 10 years, we had these bulky computers which were equivalent to the size of room. If I consider the automotive industry, then aerodynamics of the vehicle was not even in the picture. And also there was a time when wipers of the vehicle has to be operated manually. So point being, every single design starts with the need. As Plato said, need is the mother of innovation. Or for some people, it might be just passion and drive to do something new. But most of the product around you start with the need. For example, if you have a fan, then it might happen that the fan is producing so much noise, and that's why a new design of the fan was created. Just to give another example, in terms of automotive industry, it might happen that existing vehicle does not have the good mileage or the aerodynamics of the vehicle also needs some improvement. These are nothing but the needs or the improvement which we have to do in the next year model. Now one question will again come into mind as to what is the source of the need or who gives us the need. Well, the need is usually conveyed to the engineers through the customer feedback. In your life also, there is going to be a lot of instances where you will be asked to give the feedback. That feedback will serve the purpose of a need. Most of the people, when they use the product, they will leave the feedback, and from that feedback, company will understand what exactly customer want. And that want is nothing but the need for which we require to produce a solution. Now once the need is properly defined, the higher management will give this task to the appropriate team. What happens next is manager usually call up the team leader. He will explain the problem to the team leader. Then team leader will take a meeting of its engineer and explain the problem to the engineers. Then engineer will give the possible solution. Kindly keep in mind, all the things that I am explaining over here, they are in the layman terms. Of course, there are going to be lot of intricate detail, but just to get the overall idea, I am explaining these things. So, once the team leader explains the problem to the engineer will think about the possible solutions. Since there are lot of engineers working on the same problem, they might have the different ideas to solve the same problem. Furthermore, it is a bit difficult for an individual to explain his ideas to another person. And you might have experienced this by yourself also. Generally, people have a lot of crazy ideas and the imagination. But when they try to convey their ideas to the other person, the meaning of the idea does not get properly conveyed. To tackle this issue, PLM has another stage which is known as a concept stage. You can think of the PLM as the different stages. One stage we have already discussed which is known as a need, and we are moving on to the second stage which is known as a concept stage. Now in case of concept stage, the ideas or the possible ways of solution is explained to the entire team through the various methods. For example, we can perform the sketching or we can go for the clay modeling also. Here you can observe the images. I have the freehand sketching of the vehicle. So generally, whenever the automotive company try to develop a new car, they will always first go for sketching, because with the help of sketching, it is very easy to produce an idea onto the paper. See, it will be crazy that the company will directly build a car. It will be very difficult to predict the end result. So usually in the concept stage, your idea will be drawn onto the paper, or you can go for clay modeling also. So, in the initial stages of design, engineers will create a freehand sketches of possible automotive design or any product design for that matter. Now those design will get validated through our PLM cycle or through our PLM stages. Another way to produce a concept is to go for clay modeling. As you can see in the images, the sketching is a very good method of representing the idea. But with the help of clay modeling, we can capture the intricate detail of our model. For example, pay attention to the alloy wheels. In case of sketching, you are just getting overall idea about the alloy wheels. But if you do the same thing in the clay modeling, then all the intricate detail related to the alloy wheels will be available in the clay model. So usually we perform the sketching, and once the sketches are done, we will go for the clay models. And believe me, sketching and clay modeling is not only done for the car or automotive industry, but it can be done for the various general purposes as well. For example, here I have the freehand sketches of the fan. So as you can see, in the concept stage of the design, we are interested in the multiple solution and how they will look in the real life. Recently only, we had the case study where the concept sketches of auto rickshaw have been made. There were nearly hundreds of concept sketches for that auto rickshaw. Now in concept stage itself, it might happen that your team has lot of solution. So let us say 3 ideas or the concept which were very good to solve the particular engineering problem have been chosen. But at the end of the day, we are going to manufacture only one solution for it. So here we have to choose only one idea out of those 3 very good ideas. Whatever we have seen so far, all these things are in the physical world. The digital twin of those particular things have not been made. Let it be sketches, clay models, though flexible, but when it comes to the changing some portion or some part, it will be little bit tricky. For example, let's say you have created these alloy wheels, but later on some of your colleague or some of your teammate has a better idea to create the alloy wheels. Then to include that idea in your stage, you will have to start from the beginning itself. You cannot start from the middle position. Now to tackle this issue, PLM has another stage which is known as an CAD. So far, we have seen 2 stages, which is need and the concept. Now let us move on to the third stage, which is known as an CAD and which stands for computer aided design. With the help of CAD, we can produce a parametric design. Parametric design is the one which is fully constrained using the dimensions and the constraint. When we were generating the concept using the clay model or the sketches, at that time we were not using any dimension. But for the digital twin, we require the dimension. With the help of CAD, we can give the appropriate dimension and appropriate constraint between the different components. By the way, some of you might not be aware of the constraint. So you can think about the constraint as the relation between the 2 entities. So it might happen that the 2 entities are at some particular angle, or 2 entities are perpendicular or parallel. So those relations are nothing but the constraint. On my screen, I have the model of the car which is made in the SolidWorks software, which is a commercial CAD package offered by the Dassault system. In another picture, I have another CAD model which is housing made in the NXCAD, another popular commercial package from the Siemens solution. There are a lot of popular CAD packages. For example, we have the SolidWorks and CATIA from Dassault system. We have NXCAD from Siemens PLM solution. we have Creo from PTC, and we have Fusion 360 from Autodesk, and there are so many available. Your organization might be using one or more packages from this list. If you remember, in the concept stage, we had finalized 3 concept or 3 design. Now in CAD, we are going to design all those 3 ideas using the parametric concept. That means they will have the dimension and the constraint. Now to choose the very best idea out of these 3 ideas, we are going to go to the next stage, which is known as an CAE. CAE stands for Computer Aided Engineering. Using the CAE, we are going to validate all of our 3 design, and out of those 3 design, one which gives the optimized solution, we are going to finalize that design. In case of CAE, we can do various types of analysis such as crash analysis, drop testing, various durability, NVH and CFD analysis in order to validate the product. So on my left screen, you can see there is an image of a car crash testing. And here I have the simulation for the heat exchanger. With the help of CAE, we can predict the failure before actually going for testing. There are lots of popular commercial CAE packages also. For example, we have the HyperWorks from Altair, we have Abacus from Dassault System, we have NX Nastran from Siemens PLM Solution, we have MSc Nastran from Hexagon, we have LS Dyna from LSTC, we have ANSYS Workbench, and there are a lot of available. Your organization might be using multiple of these solutions based upon the requirement. In the subsequent session, we will talk in much detail about the theoretical concept related to the CAE. But remember that CAE is the research and development department which will choose which is the best optimized solution for your particular problem. Now once the CAE department confirms that which solution is best, out of the 3 ideas, one will get finalized. Once our idea get finalized, we will move on to the next stage, which is known as an CAM. CAM stands for Computer Aided Manufacturing. With the help of CAM, we can virtually generate the toolpath. We can identify which toolpath is optimized one, and we can produce the G code and N code within the fraction of second. So on my screen you can see I have the manufacturing process carried out in the NX CAM. And here again I have the second manufacturing process again carried out in the NX CAM. There are multiple popular CAM packages available such as NX CAM, Master CAM and Del CAM. Once the virtual manufacturing is done, we can go for actual manufacturing using the G code and M code sent by the CAM department. And once the actual manufacturing is done, we will go for the quality. And once our product is approved by the quality department, we will go for the sales and services. Sales and services department will carry out the feedback throughout the service. And same feedback will be taken as a need. And the same cycle will repeat again and again and again. So in the end, the development of our design will never end. There will be always some need, some requirement from the customer, and in the next design iteration, we will have to satisfy that need. So let me quickly summarize everything that we have talked so far. In order to keep track of product from its birth to the recyclation, we will have to monitor that product during the various stages. These stages are very well defined in the PLM, which stands for Product Lifecycle Management. PLM start with the need as a problem and go through the various stages such as concept, CAD, CAE, CAM, manufacturing, quality and sales and services. I hope at the end of this session you got the overall idea about the PLM. We will meet in the next session. Till then, take care. Goodbye.